Hello everyone. In this session, we'll be dealing with the next chapter, that is semiconductors, diodes and applications of diodes. So in order to understand what exactly is semiconductors, let us begin with band theory of solids. All solids in nature will be having a number of atoms. Number in the sense it can be a million, or trillion, a number of atoms will be present in each and every solid, and these atoms are responsible to give a particular shape, particular size, and some of the properties of that solid. Atom on a whole is nothing but centrally it will be having nucleus surrounding which will be having electrons. In the nucleus will be having positively charged particles which are called as protons, and the electrons which are surrounding the nucleus are negatively charged. So centrally it will be having nucleus which will be having positive number of charges which are called as protons, and surrounding the nucleus will be having a number of orbits, circular orbits or elliptical orbits is nothing but a path in which the electrons will be revolving surrounding the nucleus. So here in this diagram I have written 1, 2, 3, 4, 4 number of orbits. Each orbit is having a capacity to hold electrons depending upon the orbit number. This one this one will be called as the first orbit. So this is the first orbit, this is the second orbit, third orbit, and the fourth orbit. The orbit which is very much closer to the nucleus will be named as the first. Next comes the second, third, fourth, and so on. And the electron number which are present on each of the orbits will be decided using this formula 2n square, where n is nothing but the orbit number. For the first orbit, n value will be equal to 1. So, the number of electrons holding capacity of the first orbit will be equal to 2 into 1 square, which is nothing but 1. So, 2 number of electrons will be placed in the first orbit. Similarly, coming to the second orbit, n value will be equal to 2. So 2 into n square, which is equal to 4, 4 into 2, which is equal to 8 number of electrons can be placed in this second orbit. And each atom will be having different energy level depending upon the orbit number and depending upon the bands. This is the edge of the nucleus. From here till here, the energy of the nucleus, the energy of an atom will be different. And from nucleus, from this region to the second orbit region, the energy will be different. And from this region to this region, the energy level will be different. And that we are going to study in energy band diagram. And the particles which are revolving the nucleus are negatively charged, and we are going to call them as electrons. So according to this diagram, here n is equal to 1, n is equal to 2, n is equal to v, or n is equal to 3, n is equal to 4, like this. Each and every particle will be having different number of electrons, and accordingly the orbit number will be filled. Not all of the orbits can be completely filled. Not all of the orbits can be completely filled ಅಂತ ಹೇಳಿದ್ರೆ, suppose I am having one molecule which is having 12 number of electrons ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. 12 number of electrons ಅಂತ ಹೇಳಿದ್ರೆ, this is the central nucleus ಆದಮೇಲೆ first orbit ನಲ್ಲಿ two electrons will be placed, and out of 12 I'll be left with 10, because 10 minus 12 minus 2 is equal to 10. And out of 10 number of electrons, 8 number 1 2 3 4 5 6 7 8 number of electrons will be placed on the second orbit, and remaining I'm having 2 number of electrons that will be placed in the third orbit. But in the third orbit, according to the 2n square formula, 2 into third orbit in the sense 3 square, which is equal to 9. 9 2s are 18. 18 number of orbits can be placed in the third orbit, But here in this, according to this molecule, there are only 12 number of electrons on the head. First orbit is completely filled, second orbit is also completely filled, whereas the third orbit is not completely filled because only two number of electrons are placed, and I'll be having remaining 16 number of empty spaces. Remaining 16 number of empty places, which are called as holes. So in an orbit, the electrons can be completely filled or partially filled. According to the place of an orbit, the energy band level is different. The energy possessed by those orbits are different. The orbit which are very much closer to the nucleus will be having more energy compared to the orbit which is very much far from the nucleus. So that we are going to see over here. Band energy in electron volt, EV in the sense electron volt. In the example what we just discussed now, where 12 number of electrons were present. So 12 number of electrons now place ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ we required only 3 orbits, right? So the first two orbits were completely filled, whereas the third orbit was partially filled. And the electrons which are present in the last orbit, according to this example, third orbit itself is the last orbit. So electrons which are present in the last orbits are called as valence electrons. So the energy possessed in these valence electrons, I'm just discussing about only one atom, but if I'm going to consider any solid, there are a number of atoms where each atom will be having these valence electrons, and the energies of all these valence electrons put together will be called as a valence band, or a band in the sense all of the valence electrons or all the last orbits of the atoms will come in a single band, which is called as the valence band. And what exactly is this conduction band? Conduction band ಅಂತ ಹೇಳಿದ್ರೆ as soon as an energy is provided externally for an atom, I'm having an atom here, this is a central nucleus, and I'm having an atom, this is the outermost orbit, that is I'm having 4 number of valence electron ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. If I'm going to provide any external energy, either in the form of heat energy, light energy, any form of energy, the electrons which absorb these energy are nothing but the electrons which are uh, present in the outermost orbit, that is the valence electron. These valence electrons will absorb that energy, and as soon as they absorb the energy which is provided externally, they become free from that place and become a free electron, leaving an empty space over there, because the energy uh, given externally will be more than the energy possessed by the central nucleus. So the valence electron will now become a free electron, and there will be an empty space created in the outermost orbit. So, like this, a number of free electrons can be created, and if we are going to consider all those free electrons together, then we are going to call that as a conduction band. Okay, the energy levels will be completely different in the first orbit, second orbit, or the valence band or the conduction band accordingly. Fine. And what is the charge of an electron? This is the most frequently asked question. One mark question alli keltare. What is the charge of an electron? The charge of an electron is 1.602 into 10 to the power of minus 19 coulombs. What is the mass of an electron? 9.1 into 10 to the power of minus 31 kg. The radius of an electron 1.9 into 10 to the power of minus 15 meters. So here we have already discussed about that. Last orbit of an atom is called as valence band. Electrons present in the valence band are called as valence electrons. Conduction band is the uppermost energy band next to the valence band, and the conduction band electrons are called as free electrons. As soon as we provide energy externally, the electrons present in the outermost orbit, they absorb that energy, and they are set free into a next level where that electron will be called as a free electron. Okay, and these free electrons are responsible for the conduction of current. Now let us try to understand what is this energy band diagram. In order to understand the energy of these atoms, understanding these energy band diagram is very important. So in this energy band diagram, we are having three important things. One is the valence band, the conduction band and the forbidden energy gap. Valence band and conduction band ಅಂತ ಹೇಳಿದ್ರೆ valence band is a place where the valence electrons are present. ಬರೀ ಒಂದೇ ಒಂದು ಆಟಮ್ದಲ್ಲ, ಪ್ರತಿಯೊಂದು ಆಟಮ್ದು valence electrons ಇರುವಂತ ಬ್ಯಾಂಡ್ ನ ಇರುವಂತ ಪ್ಲೇಸ್ ನ we are going to call that as a valence band. And the electrons, that is the free electrons, ಎಲ್ಲಿರುತ್ತೋ ಅದನ್ನ ನಾವು conduction band ಅಂತ ಕರಿತೀವಿ. Because these free electrons are responsible for the conduction of current, so we are going to call them as the conduction band. And the space between the valence band and the conduction band is called as forbidden energy gap. Both of these valence band as well as the conduction band might be completely filled or partially filled or sometimes empty. In the sense, valence band ಯಾವತ್ತೂ empty ಇರಲ್ಲ. It can be partially filled or completely, that is fully filled. Whereas this conduction band can be sometimes empty or it can be partially filled also. So according to these energy band diagram, we are going to classify solids as conductors, semiconductors and insulators. So now let us try to understand what exactly is these conductors, semiconductors and insulators according to this energy band diagram. I already told you that we will be having three important things in the energy band diagram. One is the valence band, the other one is the conduction band and the other one is the forbidden energy gap. So depending upon the energy gap between the valence band and the conduction band, we are going to classify these conductors, semiconductors and insulators. So here I am having three separated diagrams: conductors, semiconductors and insulators, which deals with these energy bands. So in a conductor, there is no energy gap between the valence band and the conduction band. That is, the forbidden energy gap is not present between the valence band and the conduction band in case of a conductor. Whereas coming to an insulator, there is a large amount of energy gap, forbidden energy gap between the valence band and the conduction band, and it is in the range of 5 electron volt. Coming to the semiconductor, so what exactly is this semiconductors first of all? Semiconductor is nothing but a material whose conductivity lies between a conductor and an insulator. I mean to say, sometimes it can act like a conductor and also as an insulator. If the energy is provided externally, they act like a conductor, otherwise it's going to act like a insulator. So, coming back to this, in a semiconductor, the forbidden energy gap between the valence band and the conduction band is 1 electron volt. So what exactly is this a forbidden energy gap? Why is there a lot of difference between the forbidden energy gap in conductors, semiconductors and insulators ಅಂತ ಹೇಳಿದಾಗ, conductors ನಲ್ಲಿ if only a small amount of energy is provided externally, the valence band, that is the electrons which are present in the outermost orbit, they are going to absorb that energy and they become free electrons, which are called as, which are responsible for the conduction of current. So we can easily tell that there is a very small gap between them or even no gap between the valence band and the conduction band in case of a conductors. And examples for these conductors you have already studied regarding this in your school level. Copper, aluminum, all metals come under these conductors. ಅದೇ ಇನ್ಸುಲೇಟರ್ ಬಂದಾಗ, if the energy is provided externally, ಎಷ್ಟೇ ಎನರ್ಜಿನ ಹೊರಗಡೆಯಿಂದ ನಾವು ಸಪ್ಲೈ ಮಾಡಿದ್ರೂ ಕೂಡ, the electrons which are present in the valence band, that is the valence electrons, can never jump from the valence band to the conduction band. The valence electrons can never become a free electrons in spite of providing external energy. So ಅಲ್ಲಿ ನಮಗೆ current conduction ಆಗಲ್ಲ, because we just saw that for the current conduction we need free electrons. So in an insulator, there is a large energy gap between forbidden energy gap between a valence band and the conduction band, which is of a range 5 electron volt. Coming to a semiconductor, the forbidden energy gap between the valence band and the conduction band is just 1 electron volt, because in a conductor there is no energy gap, whereas in an insulator there is a large energy gap of 5 electron volt. I already told you that in a semiconductor the conductivity lies between a conductor as well as insulator. So the forbidden energy gap is ನಾಟ್ ದೇರ್ ಅಂತ ಹೇಳೋಕ್ಕಾಗಲ್ಲ ಅಥವಾ ಇಟ್ಸ್ ಟೂ ಮಚ್ ಅಂತಲೂ ಹೇಳೋಕ್ಕಾಗಲ್ಲ. ಇಟ್ ಈಸ್ ಇನ್ ದ ರೇಂಜ್ ಆಫ್ 1 electron volt. And the example for these semiconductors is germanium and silicon. These are the most widely used semiconductor devices. Now let us try to understand the atomic structure of silicon and germanium. If I am going to talk about silicon atom, in silicon we will be having 14 number of electrons, and in germanium we will be having 32 number of electrons. So I already discussed regarding this formula 2 to the power of n square, where n is the orbit number. Using this formula we can easily draw the atomic structure of silicon as well as the germanium. Silicon ಅಲ್ಲಿ 14 number of electrons ಆಗಿರೋದ್ರಿಂದ the first two electrons will be placed in the first orbit, the second two will be the second 8 will be placed in the second orbit, and 8 plus 2 ಅಂತ ಹೇಳಿದಾಗ 10 ಆಯಿತು. ಇನ್ನು ಮಿಕ್ಕಿದ್ದು 4 ಇದೆ. So 4 number of electrons will be placed in the third orbit. So here we are having 4 number of electrons in the outermost orbit ಅಂತ ಹೇಳಿದ್ರೆ these 4 electrons which are present in the outermost orbit itself will be called as a valence electrons. Coming to this germanium atom, germanium atomic structure bardaglu kuda using this same formula, we can easily see that in the last orbit again we are having 4 number of electrons. I mean in the germanium atom also we are having 4 valence electrons. So in case of both germanium as well as silicon, there are 4 valence electrons. So 4 valence electrons silicon allo ide, 4 valence electrons germanium allo ide. That is in case of lattice structure of semiconductors. If you are going to look into this diagram, here how we are going to write this, how we are going to draw this ಅಂತ ಹೇಳಿದಾಗ silicon is having 4 number of valence electrons. ಹೌದಾ? Silicon is this atom. Silicon is having 4 number of valence electrons ಅಂತ ಹೇಳಿದ್ರೆ ಈ ತರ ಬರಿತೀವಿ. This is in case of one atom. Like this, we'll be having a number of other atoms. So each and every atom will be interlinked together to give a particular size and particular shape to any of the solids. So this is one silicon atom. I'll be having such a number of silicon atoms which are very much closer to each other, and each atoms will be interlinked together with a separate bond, what is called as a covalent bond. Covalent bond anta irutte. Because of that each atoms in a solid will be interlinked together. ಎರಡೂ ಕೇಸ್ನಲ್ಲಿ ಸಿಲಿಕಾನ್ ಆ್ಯಂಡ್ ಜರ್ಮೇನಿಯಂ ಎರಡೂ ಕೇಸ್ನಲ್ಲಿ ನನಗೆ 4 ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರೋದ್ರಿಂದ ದ ಡಯಾಗ್ರಾಮ್ ವಿಲ್ ಬಿ ಮಚ್ ಸಿಮಿಲರ್ for both silicon as well as germanium. So according to this, the bond which is holding each atom is called as a covalent bond. Now let us see the different properties of semiconductors. So these semiconductors are tetravalent. Tetra stands for 4. Valent means valence electron. So we have seen that in both the cases there are 4 number of valence electrons. ಹಾಗಾಗಿ ಇದಕ್ಕೆ tetravalent covalent bonded crystalline substance. So this is the very first property. Coming to the next, semiconductors are perfect insulators at absolute 0 degree temperature. At 0 degree temperature ಅಂತ ಹೇಳಿದಾಗ we are not giving any kind of external heat energy. So I already told you that these semiconductors will act like a conductor when an external energy is provided. External energy can be either in the form of heat energy or light energy. So at exact absolute 0 temperature, the semiconductor will act like a perfect insulator. And the next property of these semiconductors are semiconductors have negative temperature coefficient of resistance. That is, if the temperature of these, if the external temperature what we are applying to this semiconductor increases, then the resistance of that semiconductor decreases. Resistance ಏನಾಗುತ್ತೆ decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ with the increase in the temperature. That we are going to deal with later. The next property of these semiconductors, the conductivity of a semiconductor is proportional to impurities added. Oh, so what is this impurities? Another next topic. Note. So we are going to add the impurities. Impurities in the sense we are going to add other atoms apart from these silicon and germanium in order to increase the conductivity. So these are the four important properties of semiconductor. The next topic is types of semiconductors. These semiconductors are broadly classified into intrinsic semiconductors and extrinsic semiconductor. And again, these extrinsic semiconductors are furthermore classified into p-type semiconductors and n-type of semiconductors. So let me stop this session at this point. In my next session, let us deal with what exactly is the meaning of intrinsic semiconductor and extrinsic and different types of extrinsic semiconductors. Thank you.